Assalamualaikum and very good day. Hello and welcome brilliant minds and a curious soul. Today, we're diving into a journey of innovation and sustainability where technology meets eco-consciousness. Buckle up as we introduce you to our groundbreaking project, the IoT-Reversed Vending Machine with Rewards, a smart solution that's here to revolutionize the way we think about recycling. One bottle and can at a time. Let's embark on this green adventure together and explore how we're turning the tide on waste, one reward at a time. We will go into the introduction. The IoT-Based Reversed Vending Machine (RVM) with Rewards projects represent a groundbreaking approach to recycling and environmental sustainability. By integrating IoT technology into a traditional vending machines, this initiative enables users to effortlessly deposit recyclable items like plastic bottles and cans, bridging the gap between individual actions and global environmental impact. Utilizing cutting-edge sensor and user-friendly interface, the RVM offers a seamless and engaging recycling experience. What sets this project apart is the innovative reward system, encouraging recycling efforts through incentives like discount coupons and charitable contribution. Additionally, the project generates valuable data and consumption patterns and recycling behavior, empowering stakeholders to make informed decisions in waste management and policy making. Ultimately, this initiative not only proposed a solution but also paved the way for a cultural shift towards responsible consumption and environmental stewardship, demonstrating the transformative power of technology in driving meaningful change. We will go to the problem statements. The first one is sufficient user engagement. Current recycling methods lack active participation due to a lack of initiative leading to the limited engagements. The second one, lack of real-time data. Absence of real-time data collections, tracking recycling patterns and optimizing environmental initiative. The third one, underutilized vending machine. As we know, traditional vending machines have not been effectively used to promote recycling, missing an opportunity to encourage sustainable behavior. And the last one, proposed solution. Introducing an IoT-based reverse vending machine with a reward system aims to address this challenge. This innovative approach encourages recycling through incentive, fostering responsible resource stewardship and contributing to an ecology-conscious future. Next, we will go to the material, method, and result. If you can see here, this is the flowchart for the general process of the project. I start by literature review and briefing for development of IoT-based reverse vending machine with rewards. Then, I find materials and the components. Then I will start construct the circuits. If it succeeds, I will continue by write program in Arduino IDE and upload it in Arduino Mega. And if it succeeds, I will continue by combine the software and the hardware. Then I will check the result and test the prototype. And lastly, I will do the analysis and data collections. For the block diagram, you can see here the power supply will connect to the input and the output. For the input, I will use the inductive sensor, capacitive sensor, infrared sensor. And for the microcontroller, I use Arduino Mega and ESP32. And the output is LCD and a servo motor. And for the data output, I use Blink Crowds and Blink Apps. For more detail about the component that I use, let's watch this video. The component for these projects are servo motor SD90, LCD with I2C, inductive sensor, capacitive sensor, infrared sensor. Also use servo motor MG955 for the token dispenser part. And if you can see here, this is the mechanism for sorting the waste to non-metal and metal. I also use servo motor MG955 for moving the plate around. And for scaling the weight of the waste, I use two load cell with HX711 module. Most important part in this project are the microcontroller. So the microcontroller that I use are Arduino Mega to control the waste sorting and ESP32 for the IoT waste weight scaling. I also use a 12-volt adapter for the inductive and capacitive sensor power supplies. Because of that, I need to do a voltage divider circuit on my breadboard. To avoid from the sensor send a 12-volt input to my Arduino. This can cause my Arduino burn out. Let's go to the demonstration. When user come to exchange the recycled waste to this machine, the machine will welcoming the user as you can see on the LCD. For example, this aluminium can is a metal waste. The inductive sensor will detect it and the LCD will show metal detect. The reward that given are 3 tokens. Next, this paper cup is non-metal waste. When it's been inserted, infrared sensor and capacitive sensor will detect and LCD will show no metal detect. The reward that be given are 2 tokens. Same goes to these plastic bottles. The reward also are 2 tokens. Also for this glass bottle. Now, I want to show the sorting mechanism and IoT-based scaling work in this reverse vending machine. When sensor detect either it's metal or non-metal, it will make plate under the dustbin turn around and make sure the dustbin locate under the hole that will drop the waste. After the waste fell into the dustbin, token dispenser will run and give reward based on the waste type. Load cell under the dustbin will measure the weight and display it on bin software. And if you can see here, the weight of both non-metal and metal will display on this software, and the data that be collected are being transferred to graph. You also can see the detail about the data, for example, when the waste are being inserted precisely in what time. Here is the result process of the IoT reverse vending machine. First, when user inserted metal waste in the RVM, inductive sensor will be high and LCD will display metal detect, and servo motor 1 and servo motor 3 will run and make sure the metal waste goes to the metal dustbin. Next, when the metal waste fall into the metal dustbin, servo motor 2 that act as a token dispenser will run and give user 3 tokens for the metal waste. Then, when user inserted non-metal waste in the RVM, capacitive sensor and infrared sensor will be high and the LCD will display non-metal detect, and servo motor 1 and servo motor 3 will run and make sure the non-metal waste go to the non-metal dustbin. When the non-metal waste falls into the non-metal dustbin, servo motor 2 that act as a token dispenser will run and give user 2 tokens for the non-metal waste. When any waste falls into any dustbin, load cell sensor will always measure the weight every second. Then, the data will be updated to the Blink. Last, when the weight be measured, it will display on Blink console or Blink mobile. Workers will get the real-time data through Blink and can be monitored. For the analysis, this graph shows the weight that being collected by the RVM in 1 hour. For the orange one is the weight of metal waste in 1 hour. Next, for the blue one is the weight of the non-metal waste in 1 hour. And here is the analysis, and this graph shows the value of the token based on the quantity of the waste. Next is the novelty, uniqueness and advantage. The first one is the integration of IoT. The use of IoT technology enables seamless automation and connectivity, enhancing the efficiency and user experience of the recycling process. The second one is the real-time tracking. The ability to track recycling statistics in real time provides valuable insight into the user behavior and environmental impact. And the third one Reward system, incorporating rewards for the recycling incentivize user and adds a gamified element to the encourage participants. For the commercialization potential, market demand, with increasing awareness of environmental issues, there is a growing demand for sustainable solutions like RBM. For the scalability, the modular design allows for easy replications and deployment of RBMs in various locations such as malls, computes, and public space. And for the partnership, collaboration with municipalities, waste management companies, and environmental organizations can further enhance the commercial potential and the social impact of the product. That's all for me. Thank you.